Yes, hello.
Yeah. It's good evening, I guess. Good evening, everyone. My name is Aditya Ghosh. I am from Makaut, West Bengal, and this is my teammate Debarghya Bhattacharyya from Gonanuk Institute of Technology. Today, I will be presenting our work we did during the hackathon, focusing on the DNS resolver transparency and security. DNS, the backbone of the internet, often operates as a black box. User and administrators rarely know what feature a resolver supports. Whether it uses DNSSEC for security, offers privacy features like query name minimization, or has other capabilities critical for trust and securities. Our projects tackles this lack of transparency by implementing RFC 9606 and related standards to allow resolvers to publish their capabilities in a secure and accessible way. The challenges we faced. First, no, not the challenges, but the problem we were working on, that the resolver transparency, there is no way one can find what capabilities a resolver have if it's not published by the resolver. Then security vulnerabilities, there may be a lack of DNSSEC implementation for a DNS resolver, and feature comparison. There is no tool for someone to compare DNS resolvers. Sorry. Now, what draft or RFC we have used? The problem statement reference was RFC 9606, so we have used that. It defines the mechanism for self-publishing their capabilities like policies and caching behavior. Then RFC 1035, it is the foundational specification for DNS, all query and response formats, as well as the zone file structures derived from this RFC. Then RFC 9156, it introduced DNS over HTTPS. We tried to implement that, but due to short time, we have not fully implemented it yet. Then RFC 8914, it contains the extended DNS error reporting to provide detailed feedback, helping users to diagnose resolver problems. And in last, we have used a draft which specifies what should be in the res info information. Now, what we have planned to solve? First is our plan was to implement RFC 9606. So we configured a bind-and resolver to self-publish its capabilities using specific DNS record, which was first drafted in the draft res info features, then also in RFC 9606. Then for second, for privacy and security, we integrated DNSSEC, signed zones and records to ensure authenticity. Used automated tools to manage key generation, signing and rollover to reduce manual effort. Then to build a query tool. Our main problem statement was to build a query tool for getting the resolver information. So we plan to build a Python based web app using Flux and DNS Python. Enable users to query resolver for information, compare capabilities and receive a human readable summary. How we have planned to solve it? This is already done. So next. So now my teammate Debarghya will explain what tools we have used.
So first of all, for the implementation of the resolver, we used bind9, configured it for the res info publication, and has DNSSEC capabilities now. Programming languages used to make the app was Python, deployed using Flask, and DNS Python used to query the DNS. And for containerization we used Docker. It runs on that environment, both our features, both our verification, DNSSEC verification, and the comparison feature. And testing tools, we used dig for getting the answers, and drill we mainly used to verify the DNSSEC capability. We have the code on GitHub, and for validation, DNSSEC it has RRC keys and a DNS key as well, and we use tools built into Bind9 to implement that, and we have proper documentation in our GitHub repo as well on how to implement that statement. So first of all, what we did was we implemented the ResInfo publication like it was stated on RFC 9606. There was an example provided and we formatted it just like that. Integrated DNSSEC capability, we can verify it. Build a query tool and we can compare resolvers as well using that. Enhance usability, it's a very easy to use interface. So for new ideas we have automated key management, the RRC values and the DNS key. So resolver comparison is a feature and integration with DNS privacy protocols. This is a planned future work. We'll incorporate DNS over HTTPS and DNS over TLS to provide secure and private communication so that we can better verify if the DNSSEC works or not.
So our code is available on the India Internet Foundation's account, known in the repository called Red Relay, and our design structure is very simple, as we are not building any new thing, we are just implementing a new record type which has the capabilities stated, what the DNS resolver can do. Now this is how we test it. So in the RFC it was stated that the ResInfo should give me this result. So we implemented same as it was stated in the RFC. If we use dig at our DNS resolver IP example.com, then the record type ResInfo, then we would get the answer. And as our DNSSEC is also enabled, so we added the flag plus DNSSEC, we also get the RSSEC key also. And this is for our trace route of the is the DNSSEC working fine or not. And this is a screenshot of our app. This is how the we can verify that the DNSSEC is working on. All the levels RSSEC records are shown. Next page, please. And this is for the DNS resolver query. We just have to provide the resolver IP address. Any IP address should work. The main motto of this DNS tool was to see what the DNS resolver can do. But most of the public resolver does not support this ResInfo record as of now. So we have implemented our own Bind9, which I have stated before. And so in the results we can see that this is our server and this is IIT Guwahati's own DNS. So we are not getting any feature, but we are getting the A. But in our we have stated what the resolver can do, and we have talked about the RFC which was known as extended errors 1, and what the code given here is also stated later with the proper section. If we tap that section, it will redirect me to the exact RFC to get the overall results. Next page. So what we learned? We have learned the value of standards, that why it is important to implement this kind of standards. Then we also learned the complexity of DNS. The DNS was not DNS, the complexity of DNSSEC. The DNSSEC was implemented by my teammate. I was also there. The key generation, signing and validation requires careful planning or automation to minimize human error, as it is very hard for us, as we had no prior knowledge of DNSSEC. And challenges in resolver self-publication, which I have stated before, that many DNS resolver lack support of this RFC. Then it is also important to build a user-friendly tool for providing resolver information, as most of the people don't have that time to use commands for doing this kind of things. And new work to take to working group or future work is to this kind of tool development should be standardized. It is my suggestion that these client tools, that query resolver info should be standardized. And the RFC 9606 is not being implemented. So I want this to be implemented in all the available public resolvers. And I also want a benchmarking framework that will not only compare but also benchmarks different DNS resolver. And a new draft that will addresses privacy preserving mechanism, that DOH-DOT. As in the RFC 9606, there is a section about this privacy thing, but it's very vague or not clear for us. And this is our contact details.
You are red relays, right?
Red.
So just one small question before I let you go. So can the resolver information be mandatory?
Mandatory in the RFC, it's optional.
Why? Why it has been left optional?
Maybe a resolver. I will go into that page. So in the RFC, it is stated that QNAME minimization, extended errors, and info DNS. These all three are optional as per the RFC. As maybe one DNS may not want that information to be published to public. I think it is for that only.
Did you try to make something as mandatory and see that what happens?
We have done this as it is in our server. It is just like a TXT clone. So if we give a value and a key. So if we remove something from it would work fine. So if I remove the info URL, I will get the QNAME minimization and extended errors. It's just it is written in the RFC only that it's a TXT.
One more question.
Yeah, I'm just curious to know what is the end user benefit? I mean, if they get this information.
Yeah, I am giving you my note, but what I think that I use my own DNS resolver.
Right.
So few years back when I was in class 9, my computers were receiving numerous ads. So I was very that I needed DNS or something that would block ads for that I will not receive any ads. So I searched for DNS resolvers. So there was no way to knowing that which DNS supports what. There is no documentation. As I don't know that Google's DNS is 8.8.8, what things they support. So I think that with using this as in the extended errors, the error 15, 16, 17 has blocked, censored and filtered. So for that we can know that some domains are blocked, some are censored and some are filtered. And with this URL which will given as it is self-published by the resolver only, so that they can give us a list that these are blocked, these are filtered and these are censored. This is my take of
Yeah.
it.
So can it be configurable from the end user side? Answer is no. Or
No, this is only for the DNS.
DNS side.